Okay, mostly everybody's doing okay with the documentation of their mathematics, but I kind of want to just do a little bit of a reminder and maybe some cleanup a little bit. So it's important to remember that there are a few things that are absolutely crucial. And one is that you have to rearrange your formula for the unknown first. So if I'm solving for current, now let's say I've got power, I know my power, and I know my resistance, but I don't know my current. Okay, so what I'm going to do is I'm not just going to write this. P equals I squared R. And sorry, just put my numbers in here. Let's say I had 100 watts and then my resistance was 100 ohms. Okay, now essentially what's going to happen is my current's just going to be 1 amp. And I know that because it's easy to just solve that, but that's not how it's done. You have to isolate for the unknown. So in this case, I'm going to write I. Now I know I is P over R, but it's the square root. So I'm going to write P over R, and it's the square root. Okay, so now that's one thing. Now you fill it in. I want to talk about subscripts. They're so very important. Let me just put a circuit in here. So if I'm looking for the current through R3, specifically through R3, I need to put subscripts. You have to focus on what you're actually trying to solve for. And it's especially important for series parallel circuits. So let's say that the P, I know that P R3 equals 100 watts. Okay, I also know that R3 equals 100 ohms. Okay, that's fine. I have to write that stuff there. What am I looking for? I'm looking for R3. What is my power? It's not the total power. It's not the power of this, not the power of that. I have to specifically put what's going on here. So that's R3 and that's R3. Now I can fill my values in. Now, units. Oh, did you? Oh, you didn't know. Yeah. Bah! Sorry, I get a little upset about this. What's going on? Do you not understand that you have to put the units in? Did I not tell you that before? Okay, so maybe I didn't say that. I apologize that I've never told you that before. Well, like I have an attitude or something. Okay, let's just continue. Okay, I'm going to put my values in here. First, I'm going to put this guy. Now, my power is in watts. Okay, so I'm going to write 100 watts. Okay, that's cool. Now, I'm going to write this down here, but I'm going to do it wrong. Okay, I'm going to write 100 ohms. Now, that's not a unit, that's a word. Now, the reason some people are putting that in is because they don't know where to find the ohms in their Word document. So you are using Word, I am assuming, to make your formulas. And no more formulas by hand, by the way. No, you can't do formulas by hand anymore. They have to be done on the computer. So whatever software you're doing your formulations on, that's fine. I don't care what it is, but you have to find the symbol ohms. Okay, I don't Google it if you can't figure it out. But you know what, if you're using Word, it's pretty simple because you can just go insert and then go to symbols and they'll be there. Well, there'll be one there. You can also find out what the you can also find out what the ASCII code is for that and type that in if you want. But anyway, that's got to be put in there. So now the next thing is going to be here. I'm going to write the answer 1 amp. So there are 3 steps. 1, 2, 3. I've written my formula. I've made sure that I isolated from unknown. My equal signs are all underneath each other. I cannot then just write another thing over here that equals this 100 watts divided by 100 ohms. No, you can't do that. It's got to be like this. So just do it that way. I don't know what else to say. Now, go through the PowerPoint, Professional Mathematical Documentation. It's in documentation guidelines. It's on Blackboard. I've shown it to you twice in lecture. So, and I think maybe in another video that I did as well. So it's really important that you do that. So there we go. As far as other documentations go, I think you're good. As long as you follow these guidelines, you're good. And always make sure you don't write words. So don't write the word amps. And also, yeah, that's right. One thing I need to say is that if I were to say write milliamps, like if this were going to be, the answer was going to be, let's say 0.1. Let's just say it was 0.1. So I'm going to write 0.1 amps, right? No, I'm not going to write that. You have to write 100 milliamps. So again, never ever write a number down anywhere that starts with a 0. Just don't do it. If it starts with a 0, you can't write it down. Unless it's a conversion factor, unless it's actually a number that cannot have a unit. If it's a number that doesn't have a unit, then it's okay. You can write it down that starts with a 0. That's fine. But if you can put a unit to it, that means you can apply a metric prefix to it. So if you can apply a metric prefix to a number, never ever write it with a 0. Just don't do it. Even in your formulation, even if you found, okay, you calculated something and it said 0.25, that was the answer for your current, and then you had to use your current, say for a current divider formula, don't put in 0.25, put in 250 milliamps. By the way, that's a capital A. Please use capital A's for milliamps. And the other thing is that I guess one more thing I wanted to say, let's say this was a more complicated formulation. Let's say that was 120 watts. I'm going to have to use my calculator for this. So I'm going to do all of this just in one swoop, okay? But maybe someone might want to do this. They just might want to go 120. Oh, I didn't even have to do that. 120, so that's 1.2. Okay, so I didn't mean my calculator. Okay, some people might do this. The square root of 1.2, and then that's going to equal to, actually I do need my calculator because I don't know what the square root of 1.2 is. 1.2, and that equals 1.095. 1.095 amps. Well, that's not a very good A. That's a 5, and that's amps. So, but you see, the reason you can't do this, there are 3 steps. The reason you can't do an in-between step is because this doesn't have a unit. Well, technically, the unit here is W over ohms. W per ohms. But the thing is, we don't need to do that step. You don't need to show your reader the in-between steps. You don't need to show your reader that this is how I'm going to do the in-between steps of my calculation. And you shouldn't actually have to do that because you should just type it all into your calculator. You should just type in, let me do that, square root bracket 120 divided by 100 bracket equals, bam. So that's the same number there. So even with resistance, if there's if you're calculating resistance, especially if you're using that formula where it's like the 1 over R equals 1 over RT is 1 over R1 plus 1 over R2. If you're doing that, do not write an in-between step. Just write the formula, fill it in, write the answer. Always put units. If you follow all those guidelines, you will get 100% on your calculations. It's fine. You know what? I will give away marks. If you calculate wrong, you type in numbers in your calculator wrong for some reason, and you get the wrong answer, I won't take any marks off. I will only take marks off for mathematical form. That's it.